saying is that if I could figure out a way to get students to memorize the general equation, I think there's nothing I could do more helpful than that.
Okay.
And that was kind of an epiphany that I had today, because I had a student that said his teacher's letting him make a cheat sheet where he can write all of the important equations on it.
Right.
I think our audio is working again. Let's turn the phone on.
Yeah. Whoa.
If you have both, there's interference.
Okay. Can you hear me?
Yes, I can hear you. Can you hear me?
I can hear you. Yeah.
Okay, cool. Looks like they got their audio working again.
Yeah. Well, that's weird. It's going through the. This is weird. It's going like through the computer's audio. Like my mic's not even. Doesn't say it's connected.
It sounds a little bit strange to me also, but as long as you can hear me and I can hear you, we can keep going this way. If it comes out again, I'll call you. But
okay.
I realize the most important thing that we can accomplish going into your finals is for you to memorize all of the general equations. And I'm talking there's like 50 of them.
Right.
So how do we do that? Because it occurred to me that it doesn't always make sense to just do the problems and or to have you do them in advance. What your dad was talking to me about was make sure that Dylan has done them in advance so that you can just cover the ones that he didn't do right, or you can check his work.
Right.
And I've always believed that that's the best thing to do until today.
Sure.
And then I started realizing that that would not help if you had done your homework looking at the book. And
Right.
of course you are. Everybody does that.
Uh-huh.
Everybody does their homework with the book available.
Yeah.
So how do we get you to memorize the general equations? How about we spend tonight strictly on that?
Sure.
In other words,
cool.
if I can drill you because I can do something like this. Hold on a second.
Okay.
Tell me the equation that applies to these intersecting chords inside of a circle.
Uh-huh.
Unfortunately, now you sound like you're underwater. So,
do I now?
well, not now, but you did for a little bit there.
That's weird, yeah. Okay. So for this you do A times B is equal to C times D.
Okay. If you could have a cheat sheet, this would be on there.
Perfect.
Okay. So let's just do general equations like this.
Okay.
And I will just present other situations.
Cool.
What is the general equation that applies here?
So it would be A is equal to 1/2 of 14 plus X.
Good. Notice how different those two problems were. This was a problem on segment lengths. This was a problem on degree measurement. Both of them had to do with intersecting chords. But.
Right.
All right. Let me have a look at these documents here because we don't want to spend all of our time on circles tonight. I don't want to do that. And because we've been spending so much of our time on circles, I want to make sure we cover other stuff.
Sorry, my legs are. Didn't realize my legs are in that photo.
What's that?
I didn't realize my legs were in that photo.
Oh, that's okay. Earlier today I had a problem I saw on the piece of paper and I couldn't quite read it because the guy's thumb was in the picture. It was covering up part of the problem. But let's see, is this the best one to start with? It looks like maybe I got them out of order here. Yeah, this is the one we really want, isn't it?
Perfect.
Now, here's the question. If we only had a half an hour to prepare for your semester final, I would spend the entire half hour just going over general equations.
Yeah.
Since we have 3 hours,
We can do a lecture.
we can do some problems. But I want you to begin every single problem with the general equation. And this will give me an idea of the general equations that you know and the ones you don't know.
All right.
So
for number one,
what's the area of that circle?
So you would do pi times radius squared.
Make sure when you're working with me that you do not have any pieces of paper in front of you or your book open or any of that.
Oh, it's not. Yeah, don't worry.
Well, no, I'm just saying that that's the best environment is if you don't have any reference material and you're being forced to recall from your memory.
Exactly.
So what's this in terms of pi? In other words, leave the, I know they say use.
Cool, so the answer.
But leave it in terms of pi for our purposes.
Uh-huh.
So
okay. So it would be 36 times, just 36 pi, right? Yeah.
36 pi square inches, but you're right. That's enough of an answer.
Okay.
Number 2. And what I'm noticing is that most of the material that the students are getting to review for the final is every problem is a different general equation.
Yeah.
Okay, so start with the general equation on every one of these.
Okay. All right, so for number 2 it would be base times height divided by 2.
And then do it.
Just
fill in the numbers. We don't need to do the arithmetic.
Okay.
Just fill in the numbers.
24 times 14 divided by 2.
Next problem, number 3.
All right. So this one would be base 1 plus base 2 times height.
Trapezoid. That's a trapezoid. This is a parallelogram.
So it'd be.
Parallelogram is just like a rectangle.
Is that right, or just base times height?
Base times height. The difference is you have to make sure you have the vertical height, not the slant height. In other words, the height of this parallelogram is not 10. It's 8.
No, it's 12.
No,
yeah, I was looking at that. Yeah,
It's 8. The base is 12. So this is 12 times 8. Okay.
90.
Next problem, 4. Yeah, every one of these is different. That's great. This is perfect review.
Area times the side length times the number of sides divided by 2, so ASN divided by 2.
Formula for the area? I'm sorry?
ASN divided by 2.
Okay. Fill it in.
So it'd be 7 times 8 times 6 divided by 2.
Perfect. Next one.
Okay. So the next one would be, what is this one? So it's radius squared. area is equal to radius squared.
Here, let's say the area of the shaded region. What's the general formula going to be?
Okay. Of the shaded region. Would it be? Oh, so it'd be area of the shaded region divided by 360
Well, hold on. Area of the circle
of the circle
times what?
times the area of the shaded region.
Well, what piece of the circle is that shaded region? What's
That's
this
what.
angle? What's this central angle right here?
Well, we know it's less than 180.
Well, what is it? You know exactly what it is. This one says 225. The whole circle is 360.
Okay, yeah, so you just do 360 minus 225.
Which is 135.
Yeah.
But that's not, you got to divide it by the full thing. In other words, this shaded region only represents 135 divided by 360 of that circle.
Okay.
Right? If it was 180, it would represent half the circle, which makes sense. But it's not 180, it's only 135. So whatever number that is, it's about a third. 120 would be a perfect third. And now what's the area of the circle? General.
So the area,
general
so it would
equation
be,
for area of a circle.
pi times radius squared.
So they've given you the radius. Easy.
Which is 4.
Yeah. Okay. Let's go to the next one.
And then would you just do times 135, then divide that by 360?
Yeah, you'd end up with this.
Okay.
In other words, 4 squared is 16. And now you can do some simplification if you want. But you know, in other words, I can divide top and bottom by 4 at least. Now, I don't know. At this point, I'd probably resort to a calculator.
Right. Yeah.
To get it some number of pi.
Yeah. All right, cool. So it'd be, for this one, it would be pi times radius squared minus pi times radius squared.
Okay, and let's call that pi times the big radius squared minus pi times the little radius squared. And that is actually the way they do it in calculus. This is actually a kind of classical calculus problem. So what are my numbers?
So it would be 81 pi minus 6 pi, or minus 36 pi.
No, it's pi r squared. What's the inside radius?
6.
What's 6 squared?
36.
In other words, the outside radius is 9, the inside radius is 6. So that's a reasonable answer. Of course, we'd put it in, we'd simplify it.
Right.
Okay. Number 7. I love the way they're doing this. They're doing exactly what I wanted to do, only I don't have to invent it in my head. I can just follow their guideline here.
Right.
Surface area. What is the general format for the surface area of a rectangular solid?
So we know it's base squared times, well, there's like top, bottom, right, left.
Yeah, you can call it a lot of things. Basically what we're looking at is a length, a width, and a height. Okay, those are the 3 dimensions.
Okay.
So in terms of those three dimensions, what is the surface area?
22 times 14
Well,
times 6.
let me just show you that it's going to be 2LW, because there's two of those faces, plus 2LH, because there's two of those faces, plus 2, the last combination that we have is WH.
Okay.
So that's the general formula for the surface area of a brick. And you can get the answer a lot quicker if you know this formula. Because you would have gotten there the way you were doing it, but it takes longer.
It does.
Whereas if you know this formula, you can immediately plug it in. And it doesn't matter what number you use for L, W, and H, as long as you use the different number. In other words, this thing has 3 different dimensions. Just make sure you use the 3 combinations. And that's a quick way to do surface area.
Right.
As opposed to doing it one face at a time.
Okay.
They're really going to do this on the test? They're going to mix up some questions where they want you to answer in pi and other questions where they want you to use 3.14?
I don't know. I don't think so. Like,
well,
I wouldn't.
As long as you can handle both situations, that's what's important.
Right.
Won't affect, what's the surface area of this figure?
Right. So it would be pi r squared times the height of it, right?
No. Oh, yeah. No, that's the volume. In other words, that is a prism. So if I said what was the volume of it, it would be the area of the base times the height.
Right.
Surface area is actually a much harder question.
Okay.
It's kind of the same thing as the surface area of this. If I asked you the volume of that, you would just say all 3 dimensions times one another. Same thing with a cylinder. The volume is easy. The surface area is quite a bit more difficult. What are 2 of the things that make up the surface area?
Top, bottom, and then the middle.
Okay, so let's call that 2 capital B, with capital B being the area of the base.
Okay.
And then what's the area of that middle part?
This M, like middle.
No, let's figure it out, because this is not easy. Think of a soup can. It has a label on it.
Right. Well, I guess like
if you peeled the label off and laid it out on a table, it would look like a rectangle.
Yeah.
This is the height of that soup can.
Okay.
What is this dimension?
So that dimension would be the length. Can I look up what a monopoly is for studying?
No. You need to bring your phone back.
You still there, Mr. Count?
Yeah.
Okay, cool. Sorry about that. It'd be length.
The length of that rectangle.
The length, 11. Well, now the height.
That's the height. What would the length?
So it would be 8.
Wouldn't it be the circumference of the circle? You see that?
What's that?
It would be the circumference of the circle, right?
Okay.
In other words, if you peeled the label off of a soup can and laid it out flat, the distance from one end to the other would be the distance it takes to wrap around the can, which is the circumference of that circle. So this is pi r.
Yeah. Okay.
So this becomes 2 pi r h.
Okay.
And this is probably one of the most difficult things to remember in geometry, is how you get the lateral area of a right cylinder. Okay, so the surface area of a right cylinder is 2 times the area of its base, which actually turns into 2 pi r squared, that's the area of each base, plus 2 pi r h. And we know all of those things here. Fill it in.
Right. So it would be 2 times pi times 4 squared.
Hold on.
Plus,
okay, that is 4, sorry.
Oh, you're good.
I thought it was 8 when I first looked at it.
Oh, you're good. Yeah. Plus 2 pi times 4 times 11.
And notice that as long as you know the general equation, the rest of it is always easy. It's all about knowing the general equation. Okay? Now, let's look at number 9. Is it all right with you, Dylan, if we only go a half hour tonight?
Yeah, definitely.
Yeah, it's been a very long day. I'm still recovering. I would love it if we only do a half hour tonight.
Oh, for sure.
So let's look at 9.
Okay.
Shaded area. Now, usually shaded area means subtraction problem. In other words, number 6 was a subtraction problem. It was the area of the big circle minus the area of the little circle.
Right.
That, incidentally, is called an annulus. Actually had a student the other day that had 2 questions on what is an annulus. And I had to look it up under Google. I didn't know, but that's what that is. Okay, back to number 9. So what's the shaded area? Start all the way at the top. In other words, sometimes some of these general equations, you start with the really, really general equation, and then you kind of fill it in. Well, area of the circle is where I start when I'm looking at these kind of shaded area regions. Times what?
So the area of the shaded region times like the whole circle.
No, what part of the circle is that shaded region? That's what you have to ask yourself.
Okay.
What part? Is it half? Is it a quarter? It's a little bit more than half, but how do we know exactly what it is?
It'd be the area of the shaded, which is 100. So the other part would be...
No, it's right there.
Right, so the other part would be 260. Yeah.
No, we don't care what the other part is. We're talking this shaded region right here.
Right.
So it's 225 divided by what?
So it's 225 divided by 360.
Right. That's the part. That's the part of the circle that the shaded region represents.
Right.
Okay.
Before,
so
no, I was looking at 10 before. That's why I said 100. My bad.
Okay. And now, what's the area of the circle? General form? Generally?
Yeah, so the circle would be 2 or pi times... Yeah.
So it's pi r squared times this ratio.
Right.
Now, like I said, once you get the equations, the rest becomes rather simple.
Okay.
The only thing to fill in is r, which is 8. So it's 64 pi times 225 over 360, whatever that number is.
Awesome. And then it'd be the same for...
Well, now the problems get a little more difficult. Notice that all of the previous problems were for what was on the left, either area or shaded area. Now they're making it a little harder, but the solution still lies in knowing the general equation. So what's the general equation for shaded area?
You there?
I am. Can you hear me?
You there? Yeah, I can hear you.
You can hear me? All right.
I can, yeah. Can you hear me?
Let's do number 10 and we'll finish up with number 10.
Awesome.
Okay. So the solution on number 10 is not to have an equation, what's the radius? We don't know that. I don't have any idea how to figure it out from that. But I do know what shaded area general equation is. What is it again?
So the shaded area is equal to...
What's the top, highest level general equation?
Pi times radius squared, right?
Well, okay, let's start with the area of the circle time. In other words, I think this is an important step. Because the concept is you're figuring out the area of the circle, and then you're figuring out what part of the circle is the shaded region. So it's the area of the circle times what?
So it's the area of the circle times the shaded area over 360, right?
So 100 divided by 360. Now, area of the circle is pi r squared. Still the same percentage part of the circle. It's still shaded area. And they want us to solve for r, and they've given us the shaded area. So what's the next thing I should write? Shaded area is 10 pi. Tell me what to write.
That'd be 10 pi is equal to pi times radius squared times 100 over 360.
See the beauty of writing the original equation, even if you're having to solve for r. At least now I have an equation that only has one variable in it. And I can solve for r. It's not that hard. That's just arithmetic, and I think you know how to do this part of it. Pi's cancel. Cancel that 0 with that 0. Now I get 36 is equal to r squared.
Which is r equals 6.
Yeah. So the secret for success is always to start with the general equation. And I mean start at the top. I'd actually like to see you start there, because this is where the concept comes in. In other words, this is where you decide how I'm going to solve this problem. I'm going to find the area of the circle, and I'm going to multiply it by the percentage of the circle that the shaded region represents. In other words, this is big in concept.
Exactly.
All right. Dylan, I'm going to let you go, and I thank you for letting me go.
Yeah, definitely. You get better.
I'll be glad after tomorrow, actually. Tomorrow's my last, well, it's my last big day for this week. I'm hoping next week I'll feel better. So.
Good. For sure.
All right. I'll talk to you next time, Dylan. Or tomorrow, whatever that is. I think it's tomorrow night. Yeah.
I think so, yeah. Sounds good.
All right.
Thanks, Mr. Cowan.
Bye-bye.